All right, we're going to do 1.3. 1.3, we're going to use midpoint and distance formula. These are very, very important formulas. You're going to use them throughout the entire year. On your theorem and postulate sheet, I'm okay with you writing these formulas for now. Okay? So you might want to put them on there. All right, first, we're going to call our first definition. You'll have to excuse my handwriting. Segment bisector. Cuts a segment. I spelled it right? Okay. In half. Midpoint is the middle between 2 points. And then your all-important midpoint formula. You have x1 plus x2 over 2 and y1 plus y2. Y. Oh, lame. Okay. Over 2. And then your distance formula is the square root of x2 minus x1 squared plus the square root of, plus y2 minus y1 squared. I'll undo that square root. Okay, and then we're going to apply these so you know how to use them. Okay, so a segment bisector, if I've got a segment and I bisect it, that means you do what? Okay. A midpoint is where?
Between 2 points.
Exact middle between 2 points. Midpoint formula and distance formula you will have memorized by the end of the year. You could start now. Okay. Eat my computer.
Be honest, is that lame? To make a shirt.
Let's see.
Have to change it though.
Oh, why does this take so long?
Everyone's lazy. Seriously. No one would make the shirts last year.
Okay.
I'm in your DC shirt.
All right, ladies and gentlemen, we're going to move on to number 1. Hi, teaching up here.
Sorry, Ms. Martin.
I know it took me a minute, and I really do care all about your shirts very, very much. You need to be quiet. All right. Find the lengths of the segments and tell whether any of the segments have the same length. So there's going to be a lot of writing and a lot of calculating here. We're going to use the distance form to find the distance of these 3 lines. First, we're going to find the distance between A and B. Okay? A is negative 1, 1, and B is negative 4, 3. This is x1, y1, x2, y2. Now we're going to plug it into that distance formula, which is right here. So I'm going to plug it in right into there, okay? I'm going to go to the square root of negative 4 minus a negative 1 squared plus y2, which is 3, minus y1, which is 1 squared. Does everybody see how I labeled it x1, y1, x2, y2? Yeah. And we all see how I plugged it in? Now, my suggestion is to, at this point, not go through and do all the little math, but to take out your calculator and just stick it all at once. Just make sure if it's minus a negative, you put that in there. You got to put in extra parentheses. So I put square root, parentheses, parentheses, negative 4 minus a negative 1, and parentheses squared, plus parentheses, 3 minus 1, and parentheses, squared, and parentheses. And I get 3.6, approximately. When you squiggle your equal sign, that means it's approximately. Okay, that was just to A to B. We also got to do A to C and A to D. Okay? Alright, so now we're going to do A to C. A is still negative 1, 1, and C is 3, 2. So we've got x1, y1, x2, y2, and I'm sticking it into that same formula. So I put the square root, x2 minus x1 squared, and then we have plus y2 minus y1 squared. And again, my suggestion is just to put that in your head. Yes?
Can you please explain how you got to AB? I fell behind. I
Yeah.
can't understand.
We have to find the distance between A and B, between A and C, and between A and D. What we're using, do you see that distance formula above?
Yeah.
Yeah. I'm saying what x and y, x1 and y1 is, x2 and y2 are, and then I just stick it in that formula.
But isn't the I know this is a bit off topic, but I keep getting I think I'm getting a different answer. Isn't the midpoint formula x1 plus x2 over 2?
Right. But we're not trying to find the midpoint, we're trying to find the length, which is why we're using the distance formula. Good question. This chapter puts the midpoint and the distance in the same section, but it gets a little confusing because they're very similar in some ways and very different in others. So just be careful. We're finding the distance. We want to know the length. When you're looking for length or distance, use the distance formula. I get 4.1 for this one.
If you say to plug it in the calculator.
Yeah, okay. Calculator. So you push that little second button, x squared, and you'll get the square root. And then you put parentheses, 3 minus a negative 1, and parentheses squared, plus parentheses 2 minus 1, and parentheses squared, and then another end parentheses.
Whenever I hit the second and square root, it's in there.
Do you got a different calculator than I do? Where's your square root sign? Right there. Okay, so that one, what happens when you just push it? You gotta wait till the very end to push your square root. So you put in the whole thing, and then square root it.
Are we gonna need a graphing calculator?
No. I would love to use one, and they're supposedly gonna get us one, and we can do like projects in class with it, but no, you do not need one at home to be able to do your homework. Okay. Yes? That means approximately. Because there's like 17 million decimal places, so I round it. Okay, we're going to do the last one. We're going to do from A to D. And A again is negative 1, 1, and D is 2, negative 1. So this is x1, y1, x2, y2, and then I'm just going to plug them in again. So I put parentheses, x2, which is 2, minus a negative 1 squared, plus y2, which is negative 1, minus y1, which is 1, squared. So again, I'm just going to plug this into my calculator again. So I do square root, parentheses, parentheses, 2 minus a negative 1 squared, plus parentheses, negative 1 minus 1, and parentheses squared, and parentheses. And I get approximately 3.6. Okay, you tell me which ones are the same length? AB, AC, AD. AB and AD have the same length. Do you see how we can't just count these like we did yesterday? They're sideways, we don't know how long that is. So you can't just go through and count. Okay, that's why we use the distance formula. There'll be lots of practice for the distance formula for your homework. I'm going to move up.
I remember you saying this.
Okay, are 350 feet apart, east to west, and 480 north to south. Find the walking distance between A and B. What would the distance be if the diagonal street existed between the 2 points? So first we're going to find the distance as if we had to walk along the grid. So if we walked along the grid from here to here, okay? North-south is 480, and east-west is 340. So what I'm going to do is figure out how many blocks I go north first. 1, 2, 3. So I put a 3 there. Now I'm going to figure out east to west. I'm going to go 1, 2, 3, 4, 5. Okay? And now I'm just taking the amount of feet it takes me to walk north times the number of north blocks, plus the amount of feet it takes me to walk east-west times the amount of east-west blocks I'm going. I get 3,140 feet. Do I need to go over how I got that again, or are you guys okay? You good? Alright. Now let's say we're going to take this distance to that distance. We just want to go straight. Like, let's say there's a diagonal street. Well, now we get to use the distance formula again. We have negative 680, negative 480, and 1,020, and 960. So this is x1, y1, x2, y2, and then we just stick it in that lovely formula again, which is x2 minus a negative 680, because that's x1, plus y2 minus a negative 480, because that's y2. Now I'm going to just stick this in my calculator. So again, it's parentheses, square root, parentheses, parentheses. Thank you. That's a good call. 1,020 minus a negative 680 and parentheses squared plus 960 minus a negative 480 and parentheses squared and parentheses. I get 2,227.9 approximately. So it's shorter distance to go diagonal than it is to walk north and then west. We got one more, guys, and then we'll do our writing and then our homework. Okay. The endpoints of RS are R is 1, negative 3, and S is 4, 2. Find the coordinates of the midpoint. Now we can do this without a graph, right? We've got the endpoints are 1, negative 3, and 4, 2. We know the midpoint formula is x1 plus x2 squared, over 2, excuse me, and y1 plus y2 over 2. We got x1, y1, x2, y2. So you just got 1 plus 4 over 2, and negative 3 plus 2 over 2. 1 plus 4 is 5. 5 divided by 2 is 2.5. Negative 3 plus 2 is 1, so we get 0.5. B is a little trickier. Do you guys need a minute?